The third section of the test is the electron cloud section. You remember the diagonal rule, 1s, 2s, 2p, 3s, 3p, 3d, and so on. Or you can use the periodic table, which will tell you the order. You just pick the right one. So 1s, 2s, 2p, 3s, 3p, 3d. That should be a 4s. The answer here is D. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. You just have to find the right sequence, and you can either look at your periodic table, which tells you as you go across 1s, and then it goes 2s, and then there's 2p, and then 3s, and then 3p, and then 4s, and 3d, and 4p. I'm just making the periodic tables. Does this look familiar? And it comes across, up like that. So you get the idea. All right, down here, it's higher end, down toward the bottom, but if you go down there, 4p is followed by 5s, 4d, then that's not, 4d would be followed by 5p is right, 6s, but then it would be 4f, not 5d. So I think the correct answer here is B if you get on your periodic table and follow it through. Sublevel designation, there's no such thing as a 1p. See, there's a 1s, but there's no 1p, so that's incorrect. In orbitals, we've already talked about in a previous video, there are places in space where you find the nucleus, or around the nucleus, where you find the electrons. So they're not paths, they're just a region in space where if you looked, you'd find the electron. Number 5, the maximum number of electrons in the S sublevel is 2. Remember, it was S, P, D, and F. I'm going to put the number of beds, but the beds are the orbitals. So like one orbital, 3 orbitals, 5 orbitals, 7 orbitals, but there are 2 electrons per bed, or 2 electrons per orbital. So the electrons would be 2, 6, 10, and 14. So the maximum number in the S sublevel would be 2. So the answer is B. The maximum number of electrons in the F sublevel, see what was F was over here, 7 beds, 2 electrons per, be 14. Electrons prefer not to be in the same orbital, but if they are in the same orbital, they got to spin in opposite directions. And then if you look at making the 2p sublevel, 1, 2, 3, 4, 5, 6, 7, 8. I'm putting in 8 electrons because oxygen has 8 electrons. Of those 8 electrons, 2 of them are not paired, so the answer is 2. The sublevels in the second energy level, if you go back up here, this little thing I drew earlier, 2s and 2p. That's all there is in the second energy level, so s and p. And the orbitals in a D sublevel, that was one that had 5 beds in it. So right here, 5 beds. Okay, now when there's an option, do they pair up or are they going one at a time? Well, they go in one at a time, as long as they can, so they don't have to be in the same orbitals together because they repel each other. Number 12, how many electrons in the valence? That's the outer shell of carbon. Carbon is a 1s2, it has 6 electrons, so 1s2, 2s2, 2p2. The outer shell would be the second energy level, including the s and the p, so there would be 4 electrons. The antimony, that's Sb, is, I think it's 51 electrons. So there's 2 ways to do this. You can count the series that it's in, starting on the left side of the periodic table, comes in like that, like that. That's series 1, series 2, series 3, series 4, series 5. Antimony will be in this one if you look at your periodic table. I would encourage you to do that. If you need one, go back to the front page of my website. If you also could do it like this, where you're writing the electron configuration, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p3. That would be the 51 electrons, I think. 2, 4, 10, 12, 18, 20, 30, 36, 38, 48, 51. So if you look at the outer shell, it'd be 5s and 5p. So the coefficient is 5. The answer is E. Okay, number 14, the subatomic particles that are transferred from one atom to another would be electrons. And 15 through 18, where my cursor go, there we go. This one you got to look at the blocks on the periodic table. So here's a quick high quality drawing of a periodic table. All right, so this area over here is the S. From here to here is the D block, and this is 6 electrons wide over here is the P block, and these guys down here at the bottom are 14 wide, that's the F block. So if you look at sulfur, sulfur is in the P block. So A, P block, that's A. Iron's down here in a D block, so iron's in a D block, and that is B. The F block contains uranium. So uranium is down here in the F block, so the F block is C. And that leaves the S block to contain magnesium, which is D, and magnesium's element 12 is right there. All right, on this one you just got to put them in order. So we know 2S is going to be first, and should be followed by 2P. 2P is not there. Then 3S, and that's not there, but 3P is there. Then 4S, which is not there. Then 3D, which is not, oh, 3D is there, so there's 3. Then 4P, but 4P is not there. Then 5S is not, oh, it is there. So 5S is 4. After 5S is 4D, so that'd be 5. After 4D is 5P, that'd be 6. After 5P is 6S, and then 4F, so that'd be 7. And then after 4F is 5D, then 6P. So that's your sequence, and that's the end of this section.